Hi everyone, in the given problem statement of rotate array, we are going to get an integer array nums. We have to rotate the array to the right by k steps. Now, let us understand. In this case, right, our k value is only 3. But there could be a situation the k value could be a huge number. So in order for us to optimize our code to big O of n, what we are going to do, right? So first, let's say in our case, if the k value is, let's say 10, right? Or let's say k value is, for example, 7. So if our k value is 7, which is equal to the input array length, then what we are going to see, right? After k steps, the initial array and the output array is going to be the same. So can we write in this way? Let's say the total number of rotations, or the k, would be k percentage by length of array. So in this case, the k value is 3. 3 percentage by 7 is going to be the 3. But in case it was 30, right? So our value, or the remainder, would be 2. So you have to rotate our array 2 times, because all the other rotations that you would do, right, would result in the initial array. Now, once that is done and that is sorted, can we do some slicing operation? So in order for us, right, if we look into this entire array, so this is our output array. So in the first step, what was happening? The 7th is coming at the first part, and the resultant output is 7, 1, 2, 3, 4, 5, 6. Again, after the second rotation, the 6 is going to come at first, and all the other values is going to shift towards the left. So 6 has came first, and again the 5 is going to come at first, and all the other values are going to come at last. So can we write, for example, let's say our array, our entire array is going to be array of minus k to all of the elements. So what does k minus? In our case, the k is 3, right? So our resultant array would be last 3 elements. So last 3 elements are 5, 6, 7 plus again array, and here, right, from initial elements, right, so whatever is available at the first till minus k. So here can we add 1, 2, 3, 4. This is a very easy slicing and dicing operation. So minus k is saying that last 3 elements you can add out here. So if we add this value, is this going to be 5, 6, 7, 1, 2, 3, 4. And this would be our resultant output. So in this case, right, we do not have to iterate through the entire thing. So if our code, if we have to iterate, right, through for loop step by step, our complexity would be big O of n. But if we apply this, our entire complexity is going to be big O of 1, because we are performing only one operation, one remainder operation, and another would be a slicing and dicing operation. And it would be a very, very optimized code. Now let us jump to the Python implementation. Let me write the Python code. So first, let me initialize k. So k is going to be k percentage by length of nums once that is done, and here we are able to see, right, do not return anything. We have to modify the nums in place. So in order for us to do it, so nums equal to nums of from minus k to all the elements plus nums of from all the starting element till minus k. And this would be our output. But here I made a mistake. My caps lock was on. And now if I click on run, it should submit it properly. Okay. Made a slight variable error. As you could see, the public test case is passed, and let me submit it. and our code is pretty efficient. It is running at big O of 1. Even though it is saying 22%, but I'm pretty sure it would be way more higher. And this output complexity is not always correct. So that's all for this video. See you in the next one.